I'm Regression and welcome back to my channel Operations Funda. Like and share these videos with your colleagues and your professional network. If you are new to this channel, please subscribe for more videos on operations management. Our today's session is on regression analysis. Regression analysis is a method to quantify relationship between two variables. One is independent variable while other is dependent variable. For example, sales of popcorn depends on quantity of masala sprinkled on popcorn. So here sales of popcorn is dependent variable whereas quantity of masala is independent variable. Scattered diagram is used for regression analysis. This tool is used in analyze phase of Six Sigma. So let's begin with how to perform regression analysis using Microsoft Excel. We have data collected from market survey of ice cream sales. Left column shows quantity of chips in grams. It can be choco chips or butterscotch chips. And here is sales data from different distributors. That is how much carts of ice cream cups they have sold in respective months. And here is total sales for each and every month. Here we need to analyze is the relationship between variation of chip content with sales of ice cream. For this we will use regression analysis in which scattered diagram is used. So for that select these two data, that is content of chip and total sales. Go to insert tab, select scattered diagram. Now our scattered diagram for given data is ready. Let's maximize this. So here I have enlarged this chart for better visualization. Now let's see, these are two variables. X-axis shows content of chips, that is choco chips or butterscotch chips, and y-axis denotes sales. So how much total sales we have done in respective months. So let's name this axis. Go to this plus symbol, click it, add axis titles. So you can see axis title here. We will edit this. Chip content. Let's increase font size to 16. Similarly on y-axis, total ice cream sales. Font size 16, style bold, and okay. Let's name this chart also. Ice cream sales. Let me delete these grid lines which are not necessary for us. Okay. So to know relationship between these two variables, what we need to do is we need to add a trend line. For that, left click on any of coordinate and click on add trend line. As you can see, our trend line is added. Also, click on this display equation and display R squared value. Let's change font size so that we can see this clearly. 16 bold times new number. So let's first understand what this equation and R square value means. R square is nothing but percentage of your data included in analysis. So as you can see, R is 0.937, that is 93% of your total data is included in this analysis. So as you can see, there are few coordinates lying on trend line, whereas few are very close to trend line and few are too far from trend line. This coordinates which are too far from trend line are called as outliers. In analysis, few of outliers are not included. Now this R square value shows that 93% of your data, that is 7% of your outliers are not included in this analysis, whereas other 93% of scattered coordinates are included. So higher the value of R square, better is analysis done. Now let's understand this equation. Y equals to 5.6547x plus 1.23. So this equation actually denotes slope of trend line. Why we need slope of trend line is to judge or to forecast our future sales or future events. When you substitute value of x, for this example, that is quantity of chips. So if you substitute x as 1, you will get some value for y. That means when you increase 1 gram of chips in your ice cream, your sales will increase by whatever value of y you get. So this is how regression analysis helps us to identify relation between two variables, and also it quantifies the relationship between two variables. Now one more thing to remember is positive relation and negative relation. As you can see, the direction of trend line is in such a way that increase in value of x increases value of variable on y. That is, both the variables are increasing together. That means it is positive relationship. If the trend line was in this direction, then it is called as negative relationship, because when trend line is in this direction, value on x-axis increases whereas value on y-axis decreases. Hence it is called as negative relationship. Let's see one more example. We have another example of change in employee performance with training. So we have collected some data like mistakes of employees from our quality department or their respective bosses, and number of training days from training department or HR department, we can say. So as you can see, Alex have attended 5 days of training, but he does 8 mistakes. John has attended 1 day of training and he has made 16 mistakes while performing his job. So here we need to see if our training given to employees is really effective or not. So here we need to compare two two variables, that is number of days of training these employees have attended with mistakes they do while performing their jobs. For this, select these two columns, go to Insert tab, select Scattered Diagram, and your scattered diagram for this is ready. Here I have enlarged diagram for better understanding. Here you can see on y-axis there is dependent variable, that is number of mistakes, and here is independent variable, that is number of days of training employees have attended. So let me first remove this grid line. So now you can see this very clearly, our scattered diagram or coordinates on scattered diagram. Select any of coordinate, right click on that, add trend line. Now you can see this trend line is added. Also click on display equation and R-square value. Let's increase font size for this. Bold. So now you can see equation for the slope and R-square value. As I have explained earlier, R-square is percentage of your data included in this analysis. So here approximately your 70.5% of your data is included for analysis. And y equation is given. Here we have equation for y, that is slope of this trend line. So this will help you to forecast if you increase number of days of training, how much effective or how much reduction in mistakes of your employees can be achieved. One more thing is this value, that is 14.594. So this is constant because when there is zero number of days of training given to employees, you can see here this value comes from here, that is even if you give 0 days of training, mistakes won't exceed from number of 14, means a person can do 14 to 15 mistakes. Here it is 14.59, that means for round figure we can consider 15. An employee will make 15, maximum 15 mistakes if he is given training of 0 days. Similarly, for further forecasting, you can substitute, like as you can see 6, you can substitute x value as 6. So you will get if 6 days of training is provided to employees, how many mistakes will he do? You can get from this equation. Now here you can see a relationship between these two variables is negative, because as variable from x-axis, that is training days increases, number of mistakes decreases. See, 1 day of training, here something 13 mistakes are done. Then after receiving 5 days of training, only 8 or something 6 mistakes are done, 6 or 7. So this is how regression analysis helps us to identify a relationship between two variables as well as quantify it. This equation helps us to quantify the relationship between two variables. As I said, more the value of R value, better is for analysis. So if you want to increase R value, let's see how to increase this. Let's delete this trend line. Again, left click on any of coordinate, add trend line, and select some other option. Let's select exponential, and again display equation and display R square value. So here you can see, let me increase this font size. So here you can see our R square value has increased to 0.71. That means 71% of our data is included in analysis. If you want to increase this value, again delete this trend line, left click on any of coordinate, add trend line, select some other option like polynomial, and again display equation and display R square value. Now you can see our R square value is 72.88. Let me increase the font, bold, and so here you can see R square value is again increased to 7.2. So this is the way you can increase R square value. So with respect to the option which you select for your trend line like polynomial and all, this equation is going to change, but one thing is common, that is x. So when you substitute value of x, you are going to get value of y, that is slope of your trend line, which will help you in forecasting your future events. So thank you so much for being here. If you have missed my previous video on Pareto analysis, please find the link of same in description. And stay tuned for more videos on Six Sigma and analytical tools.